Imagine a brilliant professor locked in a room, whose knowledge abruptly stops a few years ago. If you ask them about yesterday's news, they will confidently guess and make things up. This is exactly how a standard large language model behaves when asked about private or recent data. All hear and predict. How do we fix this without forcing the professor to relearn everything from scratch? We simply find a relevant reference book under the door before asking any question. This is Retrieval-Augmented Generation, or RAG. It splits the job into a librarian that retrieves facts and the professor that reads them to generate the answer. Let's see how the librarian actually works. First, we take our documents as instructions and chop them into small, digestible paragraphs called chunks. But these computers don't read words, they calculate numbers. So we run each chunk through an embedding model. An embedding translates the paragraph of text into a point in high dimensional space. Sentences with similar meaning line clustered together, even if they use completely different words. These become millions of data points in a vector database, creating a galaxy of context that's ready to be queried. And now, when you ask a question, we turn your question into a point in that exact same space. Pause and predict. How do we find the answer? Well, we just look for the closest dots to your question dot using vector search. We grab the text from those closest dots, we bundle it with your question and send it to the large language model. The model reads retrieved text and synthesizes a perfect, accurate answer with no guessing acquired. Of course, it's not foolproof. If your chunks are too large or the search fetches the wrong dots, the model will confidently give you a wrong answer based on a bad evidence. Ultimately, RAG separates reasoning from knowledge. You get the fluid intelligence of AI backed by the strict factual accuracy of your own data.